In this section, we want to start piecing together bits of information from throughout the semester to understand what the first derivative, second derivative, and limit-based statements tell us about a function, so that we can use that information to sketch the graph of a function with particular characteristics. In example 1, what we want to do is look at a graph and identify that information. But eventually what we'll build up to is being given that information and use that to sketch the picture. So in example 1, part A, we want to identify the intervals on which the function is increasing or decreasing. We can see that starting at x equals a and continuing on to positive infinity, our function is increasing. And that starting from negative infinity and working our way up to x equals a, our function is decreasing. So we'd have the intervals a to infinity and negative infinity to a. Then we want to look at concavity for this function. Keep in mind, concavity deals with whether our function is opening up or opening down. In this case, our function follows this cup shape, this bowl shape, on the entire domain of the function. So we would say that our function is concave up on negative infinity to infinity, and concave down, in this case we would say does not exist, or there is no interval where our function is concave down. Then we want to answer questions about the end behavior of the function, meaning we want to take the limit as x approaches infinity of f of x, which in this case would be positive infinity, and the limit as x approaches negative infinity of f of x, which in this case would also be positive infinity. In example 2, we want to answer those same questions, but now given a different graph. And actually, you know what? Let me go back, because I realize we gave a value for a here. We should go ahead and make use of that. So we're told that a is the point -3, -5. So this interval of increase would be -3 to infinity, and that interval of decrease would be negative infinity to -3. Here we're given the point a equals -2, 2, and we could identify our intervals of increase as does not exist. There is no interval where our function is increasing, because as we look at that function from left to right, it's decreasing over the entire domain, so we would say decreasing from negative infinity to infinity. We do get different intervals, or we get intervals for both concave up and concave down. If we look at the first half of this graph, we see that it's forming that bowl shape, that cup shape, even though the right half of that cup isn't there. So this function is concave up on negative infinity to -2 at that point A. And then to the left of A, we see that our function is following this concave down shape, this upside down bowl shape. So we would say that from -2 to infinity, our function is concave down. If we take the limit as x approaches infinity of this function g of x, we can see that our function is headed to negative infinity. And if we take the limit as x approaches negative infinity of g of x, we see that our function is headed to positive infinity in that direction.